Start with the basics. What exactly is a supernova? A supernova is one of the most powerful and luminous explosions in the universe. It marks the dramatic end of a star's life, releasing an enormous amount of energy in a short period. These cosmic events are so bright that, for a brief time, they can outshine entire galaxies. Supernovae play a crucial role in the universe by spreading heavy elements into space, which later become part of new stars, planets, and even life itself. Understanding supernovae helps us learn more about the life cycles of stars and the evolution of galaxies. Understand how a supernova happens, we first need to look at the life cycle of a star. Stars are born from clouds of gas and dust called nebulae. Over millions of years, gravity pulls this material together, forming a new star. The star spends most of its life fusing hydrogen into helium in its core, producing light and heat. As the star ages, it runs out of hydrogen fuel and begins to fuse heavier elements. This process sets the stage for the dramatic events that lead to a supernova explosion. Not all supernovae are the same. In fact, astronomers classify them into two main types, type I and type II. Type I supernovae occur in binary star systems where one star is a white dwarf. Type II supernovae happen when massive stars much larger than our Sun run out of fuel and collapse under their own gravity. Each type has its own unique process, but both result in a spectacular explosion that can be seen across the universe. Let's focus on massive stars, the ones that end their lives as type II supernovae. These stars are at least 8 times more massive than our Sun. Throughout their lives, they fuse heavier and heavier elements in their cores, creating layers like an onion. Eventually, the core is made of iron, which cannot be fused to release energy. This is the tipping point that leads to a supernova explosion. When a massive star's core becomes mostly iron, it faces a crisis. Iron cannot undergo fusion to produce energy, so the core stops generating the pressure needed to support the star against gravity. Without this support, the core collapses in on itself in a fraction of a second. This sudden collapse is the first step in the supernova explosion process. As the iron core collapses, it shrinks rapidly, reaching incredibly high densities and temperatures. The outer layers of the star begin to fall inward, accelerating toward the core. This process happens so quickly that it's almost unimaginable. Within seconds, the core becomes as dense as an atomic nucleus. The stage is now set for the explosive finale. During the collapse, protons and electrons in the core combine to form neutrons, creating a superdense object called a neutron star. This process releases a huge burst of neutrinos, tiny, nearly massless particles that carry away energy. The formation of a neutron star is a key moment in the supernova explosion, as it helps trigger the outward blast. As the core collapses and rebounds, it sends a powerful shock wave racing outward through the star. This shock wave slams into the infalling outer layers, heating them up and causing them to explode outward. The energy released in this moment is what we see as the brilliant flash of a supernova. The explosion of a supernova is incredibly bright. For a few weeks, the light from the supernova can outshine all the stars in its galaxy. This dazzling display is caused by the energy released as the star's material is blasted into space. Astronomers can observe these light curves to learn more about the explosion and the star that caused it. Supernovae are responsible for creating many of the elements found in the universe. During the explosion, the intense heat and pressure allow for the formation of elements heavier than iron, such as gold and uranium. These elements are scattered into space, where they eventually become part of new stars, planets, and even living things. After the explosion, what's left behind is called a supernova remnant. This is a cloud of gas and dust expanding outward from the site of the explosion. Supernova remnants can be observed for thousands of years, providing astronomers with clues about the original star and the explosion itself. Depending on the mass of the original star, the core left behind after a supernova can become either a neutron star or, if it's massive enough, a black hole. Neutron stars are incredibly dense, while black holes have gravity so strong that not even light can escape. These exotic objects are among the most fascinating in the universe. Some supernovae, specifically type I, occur in binary star systems. In these systems, a white dwarf star pulls material from its companion star. When enough material accumulates, the white dwarf can no longer support itself and explodes as a supernova. This process is different from the CoreCollapse supernovae of massive stars. A white dwarf is the leftover core of a star like our Sun after it has shed its outer layers. These stars are small but incredibly dense. In a binary system, a white dwarf can accumulate material from its companion, leading to a runaway fusion reaction and a type I supernova explosion. As a white dwarf gathers more material from its companion, the pressure and temperature on its surface rise. Eventually, this triggers a runaway fusion reaction, causing the entire star to explode in a brilliant flash. This is the hallmark of a type I supernova, which is used by astronomers to measure distances across the universe. Type I supernovae are incredibly useful to astronomers because they all explode with about the same brightness. This makes them excellent, standard candles for measuring distances to faraway galaxies. By observing these explosions, scientists can map the scale of the universe and study its expansion. Supernovae are not just spectacular explosions, they are essential to the evolution of galaxies. The elements they create and disperse enrich the interstellar medium, providing the raw materials for new stars and planets. Without supernovae, the universe would be a much less interesting place. Throughout history, people have observed supernovae in the night sky. Some of the most famous include the supernova recorded by Chinese astronomers in 1054, which created the Crab Nebula. These historical records help astronomers study past supernovae and understand their impact on our galaxy. Modern astronomers use powerful telescopes and advanced technology to detect supernovae in distant galaxies. By monitoring the sky, they can catch these explosions as they happen, allowing for detailed study of their light and the elements they produce. When a supernova explodes, it releases a flood of neutrinos. These tiny particles rarely interact with matter, but special detectors on Earth can sometimes catch them. Studying neutrinos from supernovae gives scientists valuable information about the explosion's inner workings. Supernova explosions can also create ripples in spacetime known as gravitational waves. These waves travel across the universe and can be detected by sensitive instruments on Earth. Observing gravitational waves from supernovae is a new and exciting way to study these cosmic events. The elements created in supernova explosions are essential for life. Elements like carbon, oxygen, and iron are all formed in stars and spread by supernovae. Every atom in your body heavier than hydrogen was once inside a star, making us all, in a way, children of the stars. Supernovae have captured the imagination of people for centuries. They appear in books, movies, and art as symbols of destruction and rebirth. Their dramatic nature makes them a favorite topic in science fiction and popular science. Supernovae are also believed to be a major source of cosmic rays, high-energy particles that travel through space. When these particles reach Earth, they can affect our atmosphere and even play a role in cloud formation. The shock waves from supernova explosions can trigger the formation of new stars. When the expanding shell of gas and dust collides with nearby clouds, it compresses them, starting the process of star birth all over again. This cycle is essential for the ongoing evolution of galaxies. Some supernovae are linked to gamma-ray bursts, the most energetic explosions in the universe. These bursts release intense radiation and can be detected from billions of light-years away. Studying them helps astronomers understand the most extreme events in space. Evidence suggests that a nearby supernova may have contributed to the formation of our own solar system. The shock wave from the explosion could have triggered the collapse of the gas cloud that formed the Sun and planets. The elements created in supernovae are found in planets around other stars known as exoplanets. By studying the composition of these worlds, scientists can learn about the history of supernovae in other parts of the galaxy. Observations of distant supernovae have provided key evidence that the universe is expanding at an accelerating rate. This discovery led to the idea of dark energy, a mysterious force driving the expansion of the cosmos. As technology advances, astronomers will be able to study supernovae in greater detail than ever before. New telescopes and detectors will reveal more about the origins, mechanics, and impacts of these cosmic explosions, deepening our understanding of the universe. The beauty and drama of supernovae have inspired countless artists. Paintings, digital art, and even music have been created to capture the awe-inspiring power of these cosmic events. Their influence stretches far beyond science. In ancient times, sudden bright stars in the sky were often seen as omens or messages from the gods. Many cultures have myths and legends inspired by what we now know were supernova explosions. Studying supernovae has led to major scientific breakthroughs, from understanding the life cycles of stars to discovering dark energy. Each new observation brings fresh insights into the workings of the universe. Space missions like the Hubble Space Telescope have captured stunning images of supernovae and their remnants. These observations help scientists piece together the story of how stars live and die. Supernovae have shaped the history of our own galaxy, the Milky Way. Their explosions have created beautiful nebulae, enriched the galaxy with heavy elements, and influenced the formation of new stars and planets. The light from a supernova can travel for millions of years before reaching Earth. When we observe a supernova in a distant galaxy, we're actually seeing an event that happened long ago, offering a glimpse into the universe's past. The mystery and power of supernovae have always fascinated people. From ancient skywatchers to modern astronomers, the quest to understand these explosions drives scientific inquiry and inspires wonder. The study of supernovae has led to the development of new technologies, from advanced telescopes to powerful computer simulations. These tools not only help us study supernovae but also benefit other areas of science and technology. As we continue to explore the universe, supernovae will remain a key focus of astronomical research. Each new discovery brings us closer to understanding the origins and fate of the cosmos. Believe it or not, supernovae have a direct connection to all of us. The atoms in our bodies were forged in the hearts of stars and spread across the galaxy by supernova explosions. In a very real sense, we are made of stardust. On rare occasions, a supernova can be seen with the naked eye, appearing as a new, bright star in the sky. These events are awe-inspiring reminders of the dynamic and ever-changing universe we live in. The study of supernovae brings together scientists from around the world. Astronomers, physicists, and engineers collaborate to observe, analyze, and understand these cosmic explosions, advancing our knowledge as a global community. Despite all we've learned, supernovae still hold many mysteries. Scientists continue to search for answers about how these explosions work, what triggers them, and what they mean for the universe as a whole. The story of supernovae is one of transformation, power, and renewal. These cosmic events remind us of the beauty and complexity of the universe, inspiring curiosity and a sense of wonder in all who learn about them. From the birth of a star to its explosive end, the journey of a supernova is a story of cosmic drama and transformation. These explosions shape galaxies, create the elements of life, and light up the universe with their brilliance. By studying supernovae, we gain insight into the past, present, and future of the cosmos and our own place within it.